So welcome to electronics section lab, and we are in basic electronics lecture series. And today the topic of discussion is the half wave rectifier. Okay, so half wave rectifier, we know that the output actually we are getting only in one half of the input AC cycle only. Okay, so in this topic we will see how the half wave rectifier can be constructed using the diodes, and then we will see the working of the half wave rectifier with the uh, as input AC signals. Okay, so let us begin our discussion. So half wave rectifier. So the half wave rectifier actually converts the alternating voltage into the unidirectional pulsating voltage. Okay, so using the one half cycle of the applied voltage. Okay, so we are getting only the one half of the applied voltage as the output. Okay, so it will convert the alternating voltage into the unidirectional pulsating voltage. So we are not getting the pure means DC voltage. We are getting some pulsating voltage. Means some AC components are superimposed with the DC. It is the known as a pulsating voltage. Okay, so the other half of the voltage is suppressed because it conducts only in the one directions. So actually we are using some diodes in this case, one diode. Okay, so we know that the diode is a unidirectional device. So that is why it conducts only in the one directions. So for one half cycle we are getting the voltage, in the other half cycle the voltage is suppressed. Okay, so let us see the circuit diagram. So you can see the output of the secondary winding is applied to the means a diode. Okay, so you can see there is a diode over here, and it is connected to the load resistor RL. So the load resistor RL we are getting the outputs. Okay, so this is our circuit diagram of a half wave rectifier. Okay, so we have a transformer. The output of a transformer is connected to the rectifier. So in this case, the rectifier is a half wave rectifier, and the half wave rectifier is consisting of one diodes only. Okay, so you can see the half wave rectifier consists of a semiconductor diode with a load resistance, that is RL. So we are having the load resistor RL, and there is a diode. It is the semiconductor diode. Okay. So the diode is connected with the series of the secondary of the transformer. So you can see this is the secondary of the transformer. The diode is connected in the series with the secondary of the transformer winding. Okay. And the load resistors RL. Okay. Next is the primary of the transformer is connected to the AC supply main. Okay, the primary of the output means it is connected to the AC supply main. So we are actually this V input we are giving as the that is the step down transformer we are using here. So we are getting only 12 volt or 9 volt of means uh, input where in the we are getting into the diodes. Okay, so that is the thing. So it is means stepping down the voltage. AC voltage. The primary of the transformer is connected to the AC power supply. Secondary of this transformer is connected to the diodes. Okay, with the series. So this is the circuit diagram. So let us see the working of this half wave rectifier. So you can see in the working of there are two halves of the AC cycle. So first there is the positive half. You can see there are two halves. So in this case only first half of the AC supply is given. So this is the one half of the positive half cycle. So during the positive half cycle of the AC supply, this end is your positive, okay, and this end is your negative. Okay, so that's the thing. So you can see the AC voltage, that is the across the secondary winding, changes the polarity after every half cycle. So this is the first half cycle. So it will change the polarity during the second half cycle. Okay, means negative half cycle. Okay, so during this positive half cycle, the input AC voltage, so it is in the positive half cycle. The upper end of the secondary winding, this is the upper end of the secondary winding, is positive with respect to the lower end. Okay, so the upper end of the positive means secondary winding is positive with respect to the lower end. Okay, so you can see this diode, actually the semiconductor diode. So it will act as a forward bias. Okay, because we are giving this positive supply. Okay, so this end is a positive, this end is negative. Okay, so this diode will be forward biased. Okay, and it will therefore conduct the current. Okay, so the diode will act as a short circuit equivalent. Okay, so you can see over here. So this is the on state. So this is the short circuit equivalent. So it will conduct the current. Okay, during this positive half of the AC supply. Okay, So this is the voltage we are means giving through the rectifier. Only this positive half cycle. Okay, only the positive half cycle we are giving this voltage. Okay, so the current flow direction, if you see, you start from here, so through the load resistor and back to the this negative terminal. So this is our current flow direction. So you can see this is the positive and negative. So V out. So in this case, the current you can see through the load resistor is from positive to negative. Okay, so we are getting the exact replica of the output input at the output. Okay, so you can see. So if the forward voltage of the diode is assumed to be 0, okay, the forward resistance output is 0. This is the means ideal diode we are taking. The input voltage during the positive half cycle is directly applied to the load resistance. Okay, RL. So therefore, the output voltage appears across the load is the same as that of the input voltage. Okay. So output voltage is same as that of the input voltage. So you can see over here. So this is our suppose VI. So if we means take the KVL, that will be V out equal to VI. Okay. So VI. So we are getting the exact input voltage at the output. Okay. So it is in the positive half cycle of the AC circuit. Okay. So next, during the negative half of the input voltage. Okay, so you can see during the negative half of the input voltage, so this end is a negative. Okay, the lower end of the secondary winding is positive with respect to the upper end. Okay, so in this case, the diode, actually this is positive and negative. This diode is reverse biased. Okay, and it does not current any current. Okay, so therefore you can see this is the negative half. Okay, we are talking about this negative half of the AC supply. Okay, so during this negative half, this end is a negative and this end is a positive. In this case, the diode is getting the reverse bias. That is why it does not conduct any current. Okay, so you can see it acts as an open circuit. So during the negative half cycle of the input AC voltage, the current and the voltage load remains 0. In the negative half cycle, no power is delivered through the loads. Okay, so you can see the diagram. So current you can see equal to 0. So this open circuit, that will be open circuit, means V out also 0 because V out equal to I into RL. Okay, so I is here is current is at 0. Okay, so that is why V out also 0. So we are not getting any voltage and current. Okay, across the load. Okay, that is the thing. So in the negative half cycle of the input supply, the current, the diode is getting the reverse bias. Therefore, it does not conduct any current. It will act as an open circuit. Okay, so output voltage also 0. So therefore, the no power is delivered to the load. Okay, so this is the circuit diagram when the half wave rectifier is in the off state. Okay, so we are getting the voltage in the means one half of the input wave only. Okay, therefore it is the called the half wave rectifier because only one half of the input cycle we are getting. Okay, so you can see that the circuit diagram means output waveform. So in this case, the output waveform you can see this is the output waveform. Okay, so you can see in the negative half we are not we are not getting any this half. Okay, we are not getting any output. So we are getting output only the positive half of the supply. Okay, so this is our diode due to this diode, semiconductor diode. So we are getting the voltage across the load resistor in the positive half cycle of the input cycle only. Okay, so that is why it is known as a half wave rectifier. Okay, so that is the all. So we have seen how the half wave rectifier can be constructed using the diodes. Okay, and we have seen how it operates with the different combinations of input voltage. That is for positive half cycles, and therefore again for it is a negative half cycle. In the positive half cycle, this diode is going to forward bias, it will act as an short circuit equivalent. Okay, so output voltage equal to input voltage. In the negative half cycle of the supply, the diode is getting reverse biased. We are not getting any output. Okay, so these are the references. Okay, so thank you for watching this video. If you have any doubt, you can free to ask me in the comment section. So thank you.